do this problem, which is part of Leetcode daily challenge, minimum length of string after deleting similar ends. So basically what this problem is, we have a string that has only the characters A, B, and C, and we are allowed to do some operation any number of times. This operation is basically picking a non-empty prefix, it can be of any length of S, and picking a non-empty suffix of the string also, which can be of any length bigger than 0. But you need all the characters of the prefix that you pick need to be equal. So you can't pick AB as a prefix. It needs to be, for example, A or BB, right? And same thing for the suffix, all the characters need to be equal. And the suffix and the prefix should not intersect. What they mean by this is, for example, here, you can't pick this as the prefix and then pick this as the suffix because they intersect in these two. So you can't do that. You'd have one valid one maybe is C and C because they are the same and they don't intersect. And the other constraint here is the characters from prefix and suffix have to be the same. So in this case, we can do both because they are C and C. But if we had a D here and C here, we can't. Okay? And then only once all of these 4 conditions are valid, then we delete both the prefix that we picked and the suffix that we picked. And the entire goal of the problem is to return the minimum length of the string after we do the operation any number of times, including 0 times. So if you, for example, look at the first example here, we can't do the operation at all because we don't have a separate prefix and a separate suffix that don't intersect that have the same characters, right? The only 2 that don't intersect are C as a prefix and A as a suffix, but these don't have the same character, and so we can't. And so what's the remaining length? It's just 2 because we can't do anything. Now if you look at this one, well, this one is a little bit easier because we can pick these 2 as the prefix since they have, this one is just 1 character, so it is the same thing for the suffix, and both have the same character C, so we can remove these 2. Okay, and then we can pick A and A. Again, we can pick only A alone because we can't pick AB because those are different characters, and since these are equal, we can remove them. So do the same thing for BB, we remove it, and we do the same thing for AA and remove it. Okay, and now we end up with 0 because we removed everything and we are left with empty string. Okay, so that's the core idea here. The length is 10 to the power of 5. So this tells you we need to find an even solution. So how can we find it? Well, we can just do exactly what the problem is asking. We need to keep track of a prefix and we need to keep track of a suffix. So this means we need to keep track of a left pointer and the right pointer. And we can just proceed and check. And no matter what characters we have here, right, if at any moment we have X here maybe and Y here, and they are different, that means we can't proceed, we should stop. Because any other letter here, okay, this would be already different. So we won't have this condition where the prefix and suffix must have the same character, right? And so we know that we will need to continue only while the string at the left and string at the right are the same. So let's just do that. So while string at left is equal to the string at right. Now, where should we initialize left and right? Well, left should be at the beginning because that's for the prefix, and right should be at the end because it's for the beginning of the suffix. And the end is just the length minus 1. Now, what is the other condition? The problem says the prefix and the suffix should not intersect. And so we are marking the prefix by left and the suffix by right. So what does it mean to intersect? Well, they may intersect either if they are in the same position or if R is to the right, is to the left of left, right? And so as soon as they intersect, like here, we should stop because then we won't have any valid solutions because right decrements and left increments. And so we need to make sure left stays smaller than right. Okay. Now what should we do? Now we need to just as long the thing here, non-empty prefix, as long as the characters are equal. So what is the character we are dealing with? Is s of left. Well, s of left is same as s of right, so you can pick whichever you use here, it doesn't matter. But as long as the current left element at left position is equal to C, we should keep going, all right? Because let's say we have, for example, AA like this, and maybe we have 1A here and B for the suffix. Now for the prefix, since we still have, maybe you have C here, since we have the same character, we should keep going because we can remove all of this and remove this one. We want to minimize the length of the remaining string, so we want to maximize what we can remove. So it doesn't make sense to stop as long as we can keep going. So that's what we're doing here. And same logic for the suffix. If we had a like this, we want to keep going until we can't anymore. And so that's the same thing here. While right is equal to this, we want to decrement because right removes from right to left. Now the other thing we need to make sure of is we didn't intersect. Okay, since we increment left and decrement right, we need to make sure we still don't intersect, right? So how to do that? Well, as long as left is less than or equal to right, and left is less than or equal to right. Now what should we return at the end? Well, at the end we should just return the remaining string. What is the remaining string? It's just right minus left plus 1. So for example, if right was 1 and left was 0, then the length would be 2. 1 minus 0 plus 1. Okay, and that's pretty much the idea behind this. So let's run it. Looks good. Let's submit, and it passes. Okay. Yeah, so that looks good. This is O of n and being the length of s, because even with these operations, as soon as they intersect, we stop. And so we will only do, combined between left and right, we will only do the length of the string. So it's O of n time, and these are constant space because they're just single variables. So O of n time and O of 1 space. Yeah, so that's pretty much it for this problem. Thanks for watching.